Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code P16F6 indicates an issue with the starter cut relay 2 control circuit in Honda Fit models from 2015 to 2020. This system is crucial as it prevents the engine from starting under certain conditions, which is primarily governed by the Engine Control Module, ECM, or Powertrain Control Module, PCM. Here, the term starter cut relay refers to a relay that activates or deactivates the starter based on signals from the vehicle's electronics. The location of this relay is typically found in the underhood fuse or relay box, necessitating removal for testing or replacement. When the system malfunctions, it can lead to high voltage being detected in the control circuit of this relay, resulting in DTC P16F6 being triggered. Understanding this code will help in properly diagnosing and restoring normal engine function. DTC P16F6 refers to a high voltage condition in the starter cut relay 2 control circuit. The starter cut relay plays a vital role in managing the electrical connection that starts the engine. When the ignition switch is turned on, the relay receives power from the PCM, which signals if the engine is in a condition that allows it to start. The relay is located within the underhood fuse and relay box, where it interacts directly with the wiring harness connected to the starter. If high voltage is detected in the control circuit, it may indicate that the relay is either malfunctioning or that there is an electrical fault somewhere in the wiring that needs to be addressed. This could prevent the engine from starting as designed, necessitating further diagnostic steps to resolve the issue. Several factors might contribute to the triggering of DTC P16F6. A common cause is a faulty starter cut relay itself, which can develop internal issues, leading to unexpected behavior, such as an open or short circuit. Alternatively, the problem can stem from shorted wiring, where the ST cut Riley 2 CL long may experience damage or degradation over time, creating incorrect voltage levels. Poor connections at the starter cut relay or the PCM could also be problematic. Loose or corroded terminals might not allow for proper electrical flow, causing high voltage readings in the circuit. It is crucial to examine these aspects when diagnosing the high voltage condition indicated by this DTC, ensuring all connections and wiring are in optimal condition. Various symptoms may accompany the DTC P16F6, offering insight into the underlying issue. The most immediate symptom is that the engine fails to start, which can be attributed to the malfunctioning starter cut relay blocking the start signal. You might also notice a high voltage indication when checking with the Honda Diagnostic System, HDS, confirming that the relay control circuit is experiencing abnormal voltage levels. Additionally, the vehicle's PCM will have registered the DTC P16F6, which will become evident during a diagnostic scan. Keeping track of these indicators is essential for determining the necessary steps to resolve the issue effectively and restoring proper vehicle operation. Understanding these symptoms aids technicians in quickly pinpointing the source of the problem during troubleshooting. The first troubleshooting step when addressing DTC P16F6 is to verify the problem using the Honda Diagnostic System, HDS. Start by turning the vehicle's ignition to the on position, ensuring all systems are powered up for testing. Next, clear any existing diagnostic trouble codes stored in the PCM to reset the system. Afterward, start the engine and observe the HDS for any pending or confirmed DTCs. If DTC P16F6 appears once again during this process, this indicates that the fault persists and you should proceed to the next troubleshooting step. However, if the code does not reappear, the issue may have been intermittent, prompting a check of connections and terminals at the starter cut relay and PCM to identify potential loose or corroded connections. In the second troubleshooting step, address the hardware component, the starter cut relay 2. Begin by turning the vehicle to the off or lock mode, ensuring safety, followed by the removal of starter cut relay 2 from the underhood fuse and relay box. This step is crucial as it allows direct access to test the relay. Utilize a multimeter or suitable testing equipment to evaluate the relay's functionality. If the relay tests as functional, you can confidently move on to the next diagnostic step. However, if the relay is found to be faulty, it must be replaced to resolve the issue behind the DTC P16F6, thereby restoring the vehicle's normal starting capability. The third troubleshooting step involves checking for shorted wires, mainly focusing on the ST-cut RLY2 CL line. First, initiate a self-diagnostic check with the HDS by jumping the SCS line. This step is essential for assessing if there are any shorts in the control circuit. Next, locate and disconnect the PCM connector A51P to isolate the components. After disconnecting, turn the vehicle to the on mode while ensuring the starter cut relay 2 remains disconnected. At this point, measure the voltage between test points 1 and 2, which consist of PCM connector A, 51P, number 34, and a body ground point. If the voltage measures 0.1 volt or less, you can conclude that the wire is functioning correctly. If issues persist, the PCM may need updating or replacement based on your diagnostic findings. After completing all necessary repairs regarding DTC P16F6, it is imperative to conduct a final verification of the repairs. Start by clearing the DTCs in the PCM once more to reset the error codes and diagnostic monitoring. Proceed to test the vehicle operation to ensure that the engine starts without issue under normal conditions. Observe for any signs of recurring problems or other DTCs that may come back during operation. This step is crucial to confirm that the previous faults have been adequately addressed and to ensure the long-term operational integrity of the vehicle's electronic system. A successful repair verification is a testament to the efficacy of the diagnostic and repair procedures undertaken. Preventative maintenance is key to averting issues like DTC P16F6 in the future. Regular inspections of all relays, including the starter cut relay 2, can help identify wear or impending failure before it leads to significant operational issues. It's also essential to routinely check the integrity of the wiring associated with the starter cut relay and other electrical components for signs of wear or degradation. Ensuring connections remain tight and free from corrosion will contribute greatly to preventing electrical faults that could trigger similar diagnostic trouble codes. Implementing these preventative measures will enhance both the reliability and longevity of the vehicle, maintaining optimal performance. In conclusion, addressing DTC P16F6 involves understanding the role of the starter cut relay and potential issues that can arise within its control circuit. Critical troubleshooting steps include verifying the problem with the HDS, testing the relay, and checking for any wiring shorts or poor connections. Effective diagnostic processes not only identify the underlying issues, but also ensure that repairs restore normal vehicle operation. Implementing regular preventive maintenance actions can mitigate the risk of similar DTCs in the future, significantly enhancing vehicle reliability. By addressing these points, vehicle integrity can be maintained, ensuring safe and reliable performance for Honda Fit owners. Please like and subscribe to the channel. See you next time.